Coming back here to our, so this is one more tool that I like. It's called the Cloud Explorer. So if I come back to my my Azure storage, I have something called the root folder. Okay, and what the root folder does is it allows me to put data at the root of my container. Okay, so for example, if I want to store something at WP demo, how do I do that? I do that by creating a root. Now this is important because you all want to break, or we all finish this and we all can pray together. It's up to you. I think let's finish and then we all can pray together. Okay, so what you can do is we can have these files at the root of the node. Why is this important? Because applications like Silverlight, when you have a cross-domain policy, the cross-domain policy needs to be at the root of the website. It cannot be on a container level, right? So for that, this root node comes in handy. So if I click on this, I have this file. I could take a share on this and I can say today, done, give it right permissions, get URL, copy shortcut. And if I paste it in here, let me do one thing. Edit it. Let's make it publicly available for the time being. So I can come in here, I can take this, so if you see here this $root, if I take this out, so I'm going at the root of the website and it still works. Okay, so this is a special folder $root that gives you access to content from the root of the website. Clear? Okay, so let's get back to our, I think I've covered most of the things here. So this is blob storage. So as I said, you have an account. So we created an account called WP demo. We created several containers. One was the $root, one was private, one was public. And in that I have my files. So I had jellyfish, I had the penguins, I had the different files in here. Now the way you store these files are in two mechanics. You can store them as a block or as a page. Right? And the way you access them, as I showed you, you have your account name. So wpdemo.blob.co.windows.net. You give it your container name and then you give it the blob name. So this is how you access your resources on the blob storage. Now the way you work with it, you have put blob, get blob, delete blob. So all the methods that you need to work with a blob are available to you on the API. You also have something called a lease blob, which puts a lease on a blob. So for example, I want to put a shared lock on that file, so nobody can write to it while I'm doing something. You can put a lease. You can put a snapshot on a blob so that only the delta is written. You don't make a copy of it. Okay? So at any point of time you want to revert back to a snapshot, you can easily revert back to a snapshot. You can associate metadata with a blob. So for example, I have a phone application, I want to take a picture, I want to upload it to my blob. But with that I want to store the geo coordinates, I want to store whatever information I would like for that particular place I took the photo on, I can add metadata. So it's like a key value pair that you add to your blob, and you can store up to 8 KB of this metadata. Fine? It's like, consider it as like a hash table that you associate with every blob. So it is adding more value to the blob. So you just don't have the file name, you have more properties that you can then go back into the application and use. Okay. So as I said, you can have the containers. What you can also have underneath the containers is way of organizing your folders. So you can add more / and segregate. For example, you could have my pictures, and you can have 2010, 2011, 2000. So these become segregation of your file structure. You can have multiple containers per account, as we saw. We have a special account called the root container that I showed you. The blob container holds a set of blobs, access policies we covered, and then we talked about the metadata, but you cannot do a search on the metadata. You cannot say give me all blobs where the picture has been taken in this location. You cannot do that. Okay. What else? We talked about shared access security. You have an ad hoc policy and you have policy based, right? Short time periods can be reused. So you take a shared access key which is valid for an hour. After an hour expires, it's gone. So it's very secure. Even if somebody manages to get the key, that resource is not available for more than an hour. Okay. And I showed you this also, how the blob works. So you have a shared request. Now here the resource is what? A container. Right? We are putting a policy on the container. Start time, end time, and the permission is right. So I'm giving a write permission on the container, and this is my shared access key. Similarly, you have policies. So here you have again on a what you call on a container. The resource is a container, and the identifier is a policy. So this is the name of the policy, and then the signature. So the policy will then define how long it's going to last, from which date to which date, what time to what time. Okay. I showed you the blob service. As I told you, there are two types of blobs, the block blob and the page blob. Now, where is the block blob most efficient is you have a huge file. Let's say you have a 2 GB of video that you want to upload. If you're going to start streaming 2 GB, it's going to take a very long time. What you could do is you could break it up into 200 megabytes of pieces. Upload all of them together as a block blob, and on the server recombine them. So the way you do that is you have this video, you break it into pieces, and then start pushing those pieces onto the blob store. Once all of them have been uploaded, you can put a block list, give the identifiers for all the blocks and the name. It's going to take all of those and combine it into a single instance. So your upload is more faster. Okay. How you break it down? It's a stream. When you open the video, you open it as a file stream. When you encode, when you're going to read the video, it's a file stream. So you say, give me a block size of 200 MB. So 200 MB read, 200 MB read, 200 MB read.
By reading?
By reading, yeah. So it's going to happen in your code. Even if you're going to take this video and upload it, you're going to do it from code.
There is a way you mean to take a portion of the video?
Yeah, so the put block is taking that one 200 megabit chunk of your video and taking it to the storage. Okay. So you have more efficiency, you have continuation and retry. So for example, if one instance fails, you can always retry it. You don't have to reload the whole file altogether again. Okay. Now on the other hand, you have the page blob. The way the page blob works is you have a 10 gigabit storage. So you say give me 10 gigabits. Now you don't use the 10 gigabytes upfront. You just request that storage. But whatever you used, you are going to be charged per the usage. And the minimum is 512 bytes. So you get chunks of 512 bytes. Think of this as your hard disk. It's a random access storage. So for example, you have an application and you have indexed files. The way you work on them is by putting pieces in pages, right? You write pieces. So using the same scenario, you can at any point of time go and put in a chunk of data at any place. So you get page size of 512. So you don't have to read the whole stream and process the whole stream. You read chunks and you can process chunks, and very efficient. Then we talked about the content delivery network. Now the way the content delivery network works is, and we'll come back to this again, is I have a resource on my blob store. Okay, the way I request it is using a GUID. So the content delivery network is going to give me a GUID. I'm going to request that service using a GUID. Now what happens is, based on where I am, I'm going to go to an edge location. So we have 24 content delivery networks around the world. So for a user is coming from South Asia, he is going to be redirected to a content delivery network in his area. He is not going to go to North America. He is going to go to an edge server. The edge server is going to see if it has that resource available. If it does not have, then it's going to request that resource from the server, download it and cache it. Now you can give it a time to live, a TTL, and say I want this resource available for 10 minutes, 20 minutes, half an hour, 1 day. You decide how long you want to cache that information. Right? Once it's downloaded to the edge network, it's given back to the user. So the second time the user requests that information, it is given back through the cache. Okay? So the second user, or the second time the same user comes back, he does not pay the penalty of having to go back to the US server. It's much faster. Right? So you have your application sitting in one data center, but you can serve the whole world using the content delivery networks.
Can keep multiple caches, versions of the same.
No. A different version becomes a different file.
No, I mean if the resource is a web page and it depends upon a parameter that the user will pass.
We are not talking about pages, we are talking about blob storage. So we are talking about the CDN works, this is not, and that's a different topic. Okay, that's a caching mechanism. Here we are talking about a resource which can be any binary file. So it can be an XML file, it can be a video file, it can be a picture file. Now keep in mind that you usually use the CDN for public data, because the CDN has no notion of security. It does not have ACLs on it, it does not know who's who. So you do not put secure information on the CDN. It's only for public information that you use the CDN. Clear? So again, when the TTL expires, you go to the same loop again. A user requests it, it's not found, it goes back to the hosting server, brings it back, stores it, and returns it to the user. Now what could also happen is, you want to expire the resources. So you can also have a mechanism where you change the GUID. So if you want to expire a resource, the resource that you are sending out, you change the GUID of that resource, right? Or you change the name. And that's also a mechanism that can be used. So it will not find it. It's going to go and download a fresh copy. So let's talk about drives. As I mentioned to you, you can use the drives to mount NTFS partitions, and underlying it, it uses the page storage. As I mentioned to you, you have two types of blobs. You have the block and you have the page. So the underlying mechanism of using an NTFS partition is the page. The benefits, some of the benefits are you can take an existing application which has a dependency on a drive, and you can easily upload it to Windows Azure, and then later on start migrating it into a traditional Azure application. You can mount blobs over the network as an NTFS drive. It can cache local data onto the instance of the server itself. So you have a local cache on the server itself where it will cache the data. Okay. As I mentioned to you, it's a page blob. It can be mounted. So you can have up to 16 drives mounted up on an instance. Okay. Now the way this works is any one instance can work with a drive at a time, and the way that works is by using a lease on the resource. So for example, I am accessing that drive, I will put a lease. When I'm done, I'm going to remove the lease so that two instances are not going to corrupt the data on that drive. Get me? I have a drive. I'm writing to picture 1 on the drive. Another instance is also trying to write to the same image. What's going to happen? You'll get data corruption, right? So you put a block on that drive till the time you don't finish. Another instance cannot use that resource. So once I'm done, the lease is removed, another instance is going to come and use the resource. Okay? So these are some of the operations that you can do. Okay? So as I told you, I don't know, it's not very clear. There's a lease that's written there. Okay, that's put onto the file. And once you get data from the drive, it is put onto a local cache. So next time when you request, it's going to check the local cache. If it is there, it's going to be brought from the local cache. If not, then it's going to be brought from the storage and then returned and put back to the local cache. So same way the CDN works, this thing works. These are some of the client libraries that you have on the drive, cloud storage drive. Let's skip some of this. Let's talk about tables. As I told you, a table is a way of storing structured data, right? So in here I have an account. Again, whatever, in our case it will be WP demo. And I can define different tables in there. And the tables will hold structured data. So in this case, it is name, email, email address, whatever. You have inserts, updates, and you have something called now an upsert. Now upsert is a combination of an insert and an update. So instead of having two transactions, because each transaction costs you money, you do an upsert. If it is not existing, it's going to insert it for you. If it is existing, it's going to update it for you. Clear? You can query the table, you can run queries on it, you can run link on it, and you can run multiple CRUD operations as an atomic transaction on the table storage. You can have properties. You can have up to 255 properties per entity, and each entity can be up to 1 megabit in size. The way you define these, and it's more clear in the next session, is you have a key value pair, a partition key, right, which defines how you are going to store your data. Now, this is an example of the storage. If you look at the first, second data rows, they are all properly date formatted. So it's a date instance. But the third one does not have a date. It has a string, right? So as I told you, the storage instance does not enforce any constraints. It takes what you give and it will put it in. Also, you can have additional properties on an element. So every element does not need to have the same properties. They can be different. And you can do filters. Now this is probably not the best way to filter it, because the best way to do it will be on the partition key, right? Because that way it's going to be indexed. These are some of the statistics on the partition key, why we use the partition keys. Number one is to locally store the data in the same location. So for example, if you are doing a partition key on a category, so all the categories of that product are going to be stored in the same location. So easier retrieval. When you are updating, they can be part of an atomic transaction. So these are some of the reasons why you would use a partition key. So if you see here, we are defining a partition key which is going to segregate our data. And the way we are doing it is we have a min key of Kenos and a max key of Kenos. So the data is going to be segregated based on the key. Now this is important. Yes?
The property of an entity, can it be a blob?
No. Can it be a blob?
Yeah.
It will be a URL to a blob. Right? So you cannot store a blob per se in a table, but it could be a link to a blob. Yes?
Like any binary data, like in SQL Server, I can put anything. Same thing here.
I think yes, you can put data in the table storage. Okay? Now, I need to come back to you on that. Whether it allows you binary data or not. But it's not very big. You have a 1 MB size on the data. So
maybe URL is the best.
URL is the best place to do it there. Okay? Now, the way queues work, okay, is it's a way of communicating between the different roles. So you set up different queues, like you set up the blobs and the tables. And the way they work is a web role is going to put a queue or a message on the queue. And a worker role is going to pick up a message and perform the job. So let's go to the example of our fluffy photos. The web role, right? So one web role, this is where I uploaded the photo, right? This web role picked up the photo, put it onto the Windows Azure storage. And in the key or in the queue, it put the message with the URL of the photo. Any of these workers here can come in, pick up that message, perform the processing on that image, put it back onto the storage device, put a message back saying I am done. It is picked up by the web role and saying a message is given back to you saying it's done. Fine? Now this is where I said you don't have RS running on these machines. Why? If you had RS running on these machines, how are you going to communicate with this? You need to talk to a specific instance, right? It does not scale out very well. With the messages, this worker role is going to, any worker role can do the processing. So for example, if you have huge files that require longer time to process, you can put more worker roles in there. And these can scale out. And this is a guaranteed mechanism of delivery. Why? Because if a worker role takes ownership of a message, that message is made invisible. It's not deleted, it's made invisible. So that the other worker roles are not going to see it. Once the worker role finishes the processing, it's going to go and delete that message from the queue. If for some reason this worker role has to die, this message is going to be made visible again. So second worker role comes in, picks it up, processes it. It's a very highly scalable mechanism to do processing, right? Any questions on this? So your question again. Now you understand why we are saying scale out, not scale up. Okay? You can do more work with more instances than doing one big machine work, or one machine doing a lot of work on one instance. Okay? So see, these are the some of the details of the queues. It's asynchronous, so the dispatching and processing is asynchronous. You don't hold down the web role or the worker role from doing processing. There's no limit to the length on the storage, except that it has to be 64 KB per message. These are list queues, right? So basically you just put in the message is retrieved. It's like a push and pull mechanism. Some of the queue operations that we can do is we can create a new queue, we can delete a queue, we can get and set metadata on the queue, and we can clear messages from the queue. On the other hand, you have put message, get message, peek message, delete message, and update message. So this is something that the worker role would basically do, right? As I said, there's a guaranteed delivery. So if for some reason, if a worker role cannot process it, then some other worker role is going to take ownership of that message and process it.
Who ensures this?
Pardon me?
Who ensures this?
The system ensures this.
I mean the queue or the other end?
No, the queue ensures that. So as I said, if you go back here, take the example of our fluffy photos. I took the image, put it onto storage, and put a message saying that process this image for me. This particular worker role came in, looked at the message, and picked it up. The moment this worker role picks up the message, it's made invisible. Okay, it's not deleted, it's made invisible. So message is not available to the other worker roles. Now something happened here. This machine crashed. Now since this machine crashed, the system knows that it was not able to process this message. So it's going to make this message visible again. This worker role comes in, picks it up, makes it invisible, processes it, puts the thumbnail back onto the storage, puts the message back in here. It's made, this is deleted, this particular message, the old message is deleted, okay, and the processing continues.
So the worker role is like a service.
That's what I said, the worker role is a service.
Regularly checking for the queue.
Regularly checking for the queue.
After that, that message is processed, then even if the worker role or that service stopped or failed for any reason,
It doesn't
won't
matter.
affect the process.
Yes. So if this worker role had to go down, the system will create a new worker role for you and delete this worker role. Clear? So this is basically what we covered now. We have blobs, we have drives, we have tables, and we have queues. The queues is the most important because it gives you a reliable delivery of messaging. Okay? Any questions on this? Yeah.
Queues are only used for message delivery, doesn't use for normal storage.
There is no storage, it's only for message delivery. It's a mechanism of transmitting information. As I told you, there is no IS running on the worker role. So the worker role, you don't communicate using web services. You communicate using queues. So the worker role does something, puts the data back onto storage, puts a message back onto the queue. The web role will pick up the message and then send it back to you. Okay?
Based on WCF?
The messaging?
Yeah.
No, it's an API. So you put a message, you pull in the message, it's all API driven. Okay? So let's go, pray, have lunch, and then inshallah we come back in an hour's time. Now, before we get started, how many of you have installed and configured SQL Server? How much time does it take?
About 30 to 40 minutes.
If you don't have to buy the hardware? Okay. Well, we'll see how quickly and easily we can set up a SQL Server database in Azure. So the whole idea is it's available to you as a service. Okay? You don't have to configure the physical servers, you don't have to configure storage, memory, performance tune it. It's there for you. You request it, you get it. In a few minutes, you will have your SQL Server up and running. Right? You just go and tell the system, I want a database, I want 1 GB, I want 5 GB, I want 10 GB, I want 150 GB. You decide how much data you want, and based on that, the system is going to go and create a database for you. Now, when we create a database, it's highly available because we create 3 instances of that database for you. So similar to the blob storage, we create 3 instances of a SQL storage for you. At any point of time, an instance dies, a second instance is promoted as a primary, and a new instance is created. So at any given time, you will have 3 instances of SQL Server running for you. Okay? It's also been designed with the scale out that we talked about. So it's easy to scale out your databases. So you don't go up, you don't go 150, 300, you scale out. So you have small chunks of databases which you scale out to. Okay? So how easy it is to get started? You choose a plan, you choose a billing option, and you're ready to go. So let's have a look at it before you do anything. Okay. we're having a network problem. Okay, so let's go back to our management portal, and we have a database section in here. Okay. So with any database, what do you need? You need a new server. So I create a new server. I select a region, click next. I give it a login admin. So for the case of us, we can say, okay, WA, Windows Azure Riyadh. Okay. Give it a secure password. Click next. Then I tell it what are the IP rules. That means that which ports am I going to open for my database to connect to, right? Who can connect to this database? So one, we are saying that allow other Windows Azure services to access this server, right? And then in terms of the IP, I'm going to put so basically I'm opening this up to everybody. I could restrict it to my IP address, right? Or I'm just for the time being opening it to everybody. And click finish. So now this is setting up a server for me on which I can now start hosting my databases. So I go and create a new database, give it a name. So we'll say Riyadh demo. I say what is the size of the database I want, right? Click OK. Now this forms my database server name. So I have this unique ID, database.windows.net. So this is my ID. And then inside that, I have a database called Riyadh demo. Fine. Now I can start working with it. I can go to manage this from the portal itself. I can test connectivity. So here I get a portal. I give it the name of the user. So we said Windows Azure Riyadh, and my secure password, and then I click log on. So this is one way of connecting to the server, right? The other way is through the SQL data server or through the SQL Server Management Studio. So if I come in here, I can go to SQL Server Management Studio. So I have SQL Server 2008 R2 or SQL Server 2012 Data Management, SQL Server Management Studio. So I give it the name of my server. So I say Control V. Sorry. I say connect. Is this connecting to my database in Azure? I have two databases there, one called the master and the other called Riyadh. Okay? So I could use the browser. So I could use the browser to administrate, design it, look at the query performance, or I can come to the management studio and do my management using the tools that I am familiar with. Okay, so you have both options. There are no jobs. There are no jobs in SQL Azure. Because you are talking about a service. The service has no notion of, you don't maintain the database. Okay? That's why I said this is a service that is running. So you are getting an instance of a database. The database has been maintained by somebody. So we are giving you a platform. You don't have to go and fine tune the database, do DB index on it or DBCC on it, make sure that the files are shrunk, increased. All that plumbing is not required. Okay? So that traditional model no longer applies. Yes?
To open using SQL Server 2010?
2008? Yeah. That's what I said. You can use 2008 or 2012 R2.
And the features of SQL Server Enterprise Edition or professional?
This is SQL Server Azure. Yeah, so this is SQL Azure. It's a database technology built on top of SQL Server 2008 R2. Okay, but if you look at what kind of features are you looking for?
Stuff like maybe the indexes.
That's what I said. You don't maintain indexes. You don't maintain those. What do you say? You don't maintain page files. You don't maintain file groups.
Like in the SQL Server Enterprise, there is an option for indexes to be live even if it is rebuilding the index. So
That's why I said you don't manage anything of that sort. You don't manage it. Somebody takes care of it for you.
even the user,
Pardon me?
even the user.
No, you create users. That's your responsibility because you are going to give access to the database. Okay, so you are responsible for creating the users and giving them the appropriate permissions. But from management perspective of keeping the data up and running, it's not your job. Okay, so that headache has been taken away from you. Okay, so let's get back to the slides. So as we saw, we create a server, we have a service head which we call, okay, and that we connect using the database.windows.net. So the XXX is your name of the server. Initially when we created it, it had only one database called master, and then we logged on to the portal and created another database that we wanted. Okay. Now you can do the same thing using PowerShell commandlets. So if you are a power user, you are an administrator and you are more familiar with the PowerShell commands, then you have the option of scripting this whole thing from PowerShell. Okay. So I can use the SQL commands, or you can use the PowerShell commands. Now, in terms of the technologies, is the same thing. You support Transact SQL, we support ADO.NET, we support ODBC, Java, PHP. But keep in mind that these drivers, other than the ADO.NET drivers, are not available on the server. So you'll have to package them with your application. So for example, you are writing a PHP application and you want to access the data on a SQL Azure database, right? You'll have to bundle the PHP drivers with your application. We support the most common frameworks, like for example, we support OData, Entity Framework, WCF Data Services, NHibernate. We support all of these. We also support most of the popular tools. So as I said, you have SQL Server Management Studio. You have the command lines tools, SQL Command. You also support third-party tools like Erwin, DB Artisan. So all of this is supporting, and there are more tools that are coming online. Fine. Now, in terms of differences on an on-premise server to an off-premise server, there is no concept of physical entities. So you don't have physical file storage. You don't have file groups. You don't say put my data on this drive, put the log on this drive. That concept does not exist. Okay? You ask for a service, you get a service. You don't manage the service. Fine? The database has to be fully contained. Now what does that mean? That means that you cannot have CLR objects. CLR. Okay? Pardon me? No CLR objects. See, with SQL Server 2008 onwards, you could write .NET code and put it into, so you could create an assembly and put it in SQL Server, right? Now, if you want your database to scale, you don't want to have dependencies on the operating system, right? Because when you are compiling a DLL, you are putting something on the operating system. You don't want that dependency. You want to have a database created like this and scaled out. Let's take an example of a multi-tenant application. I am writing an application for payroll. You as a customer come to me, say, I want to purchase your subscription. I have 100 employees. What will I do? I will go to SQL Azure, on the fly create a database, populate the tables, give you a subscription, you're ready to go. If one instance comes down, SQL Azure is going to promote the second instance, create a new instance, and give me the data back. If I am going to have dependencies on other objects, I cannot scale out. I cannot get more databases in place. Fine? So for that, it's a good, it's something good. It's not that you're losing something, it's for the benefit. Okay? So the maximum database size is not 50, it's 150. Last week, they changed the size to 150. So they have increased the size, but still kept the price the same. So some of the things that you don't have, no more backup restore. There is, as of today, no backup restore. You cannot have linked servers. Again, dependencies. We don't want to have dependencies on other objects. It has to be a self-contained database. Distributed transactions not allowed. Distributed views not allowed. You cannot have a service broker. You cannot have SQL agent. You cannot have a CLR runtime. Pardon me?
Unless the backup and restore in this case, usually, because Microsoft will take care of it.
We will take care of it. But you may need to have backup and restore. You may want to back up the database from the server and bring it to your on-premise database. And we'll talk about how you do that.
Can I take this data and put it in SQL Server?
Yes. You can take the data from SQL Server and take it into Azure. It's a SQL Server database. It has full.
That means I have control of the data.
Oh, you have control over the data. And nobody's taking the data away, that's yours. So you have full control on the data, you have full control on the permissions, you have views, you have stored procedures. All of those things are there. What you don't have is the plumbing. You don't take care of the plumbing. Okay? So I showed this to you. You have now a rich UI which you can use on the web to design and maintain your databases. Right? You have rich client support in terms of SQL Server data tools. How many of you have looked at the SQL Server data tools? Data tools. This technology was introduced to a good extent in SQL Server 2008 as DAC packs. Anybody heard of the term DAC pack? Okay. DAC pack is a way of versioning your database. Okay, and now you have separate tools called the SQL Server data tools which come with SQL Server 2012. It's also available as a standalone from the web platform installer. So if you go to web platform installer, you will see SQL Server data tools there. Okay, it also comes with the Visual Studio Dev 11. So if you install the new version of Visual Studio, which is called Dev 11, you will get SQL Server data tools with it. So this is how it looks. Dev 11. Dev 11 is the new version of Visual Studio, which is still in developer preview. SQL Server data tools. So if you come here,
What is that back?
I'm going to talk about DAC pack. Okay. So if I go to all programs, if I go to SQL Server 2012, right, this is release candidate 0, I have something called SQL Server data tools, which I have started here. And in here I can go and say new project, and if I go to SQL Server, I have got something called a SQL Server data tier application. Okay. Now the SQL Server data tier application basically creates a deployment, like when you build a Visual Studio application, it creates a binary deployment, right? Similarly, a SQL Server DAC pack is created from this kind of a project. The DAC pack is all your source code bundled into a package. So you can take this package, give it to the administrator and say, now go ahead and deploy this application. Usually what happens is, you as a developer develop applications, right? Create procedures, create views, and you take those scripts, give it to the administrator and say, now you go figure out a way to deploy this, right? There may be schema changes. There may be columns that have been deleted. There may be tables that have been deleted. Now the administrator has to go figure things out, run scripts, make sure everything is consistent, and then deploy that. What happens if you wrote a version of a database, right? Of an application, 1.0. You wrote another version of an application called 1.1. Now for some reason you have to reverse it back to 1.0. What happens to the database? How easy it is to roll back to 1.0? Is it easy? No. So that's the whole idea of a DAC pack, that you can revert back to a version of a database at any given point of time. So it gives you data versioning, source control on a database. All those kind of things are available. And this has been there since 2008. It's not something new. Okay? The tools have been improved to add more capabilities. Right? Like for example, now with the DAC pack, you have something called a backpack. Okay? A backpack is basically your data plus object. whereas the DAC pack is only objects. So if I am going to create this application, one of the things I can do is I can import scripts. So I can go and look at an existing SQL Server instance and import data from there. Okay, I can even import an existing data tier application. Fine. So let me open something that I have already imported. So I should have something here. If I come in here, if I look at my schemas, I have DBO, I have tables. If I double click on them, I'm getting a designer, I'm getting code, and see something interesting. I have something here called a local DB. It's an in-memory database of my scripts. So for example, if I open a view, or if I am to create a new view, let's take this. So I can say if I'm going to give it a dot, sorry. So select from, and then I can come in here and I can say product. I have not connected to a database. This is all being done in memory. So it goes, looks at my scripts, look at the table structure, builds an in-memory database, and is giving me IntelliSense. Okay? So I have not yet connected to a database. I am not connected to any database at all. If you see on the left-hand side, there is no database connected. I have only a local DB. Right? And it's giving me full IntelliSense. So this is the power of SQL Server data tools. Now you can version these scripts. Right? You can version these. If I come here, let me close this out. I can go to properties and build. I can say which servers do I want to target. I can say SQL Azure, or SQL Server 2012 or 2008 R2. Right? Also here, in here somewhere I can provide the version for my database. Here. So the version of my DAC. So I can say at what version is my application running at. So when I do a migration, right, I can always roll back to an instance of a database. So I have version databases. Clear? So once I have something like this, I can go and build the solution. If I come here, this is our application. Pardon me? Build failed. Why did a build fail? Okay, I was playing around with this database last time when I did the view, so I have changed something probably in the schema. But let me show you what you get. Let's go back here. C drive. This has data in it. Okay. So what I have done is I have imported this. So if you go to Codeplex, you can get this database there. Upload it to the storage account, and you can import it directly to SQL Azure. And this this is somewhere on here. So if you go here, okay, you have the Adventure Works sample backpack. So you can take this, upload it to your storage account, and from there you can import it to SQL Azure, right? Okay, so let's run through the slides quickly. So as I showed you, you have the complete development environment. It has a very nice IDE. You see, you can design it graphically or you can design it in code. Previously, the limitations were on the tools. They were not very strong in 2008. But with the 2012, the tools are really very powerful, right? You get IntelliSense on your code. It's all in memory database. So you have the data tier application framework. As I showed you, it takes your schema, and if you want data, it becomes a backpack. Okay, supports automatic versioning of the database, supports platform targeting. You can build from existing databases, or you can start from scratch. So I can just take a existing database as I showed you. You can import the script from an existing database, right? And these are some of the ways you can get the latest tools. You can either get them from web platform installer, you can get it with the SQL Server 2012 Management Studio, or you can basically use this SQL Azure import and export service. So if you go back here into the portal management, if you see here, I can export this database. So once I export it, it's going to ask me for a location to put the data there, right? And this is going to store it as a backpack. Now this is how you are going to take your data offline and import it somewhere else. So you asked me what is the mechanism of backup restore. This is how you backup restore. So if you really need to do a backup restore, this is a poor man's backup restore. Fine? We covered some of this. We can take it from the management studio. As I said, you can deploy a DAC pack, or you can load the data through the command line options also. Okay. I showed you the backpack also, how you can import and export the backpack. If you want to upgrade a DAC pack or a backpack, you can do it directly from SQL Server 2012. So for example, if I have a database, I want to upgrade it, I can do it directly from the management studio, right? Now, this is some of the things we talked about again. We have standard master database. If you want to give additional access, then you need to create your logins yourself, right? The one that you create is the admin account. It has access to all the databases. So whenever you create a new database, please go ahead and create a user account for that database and have least security on that. Okay. This is some of the standard stuff that you had already on SQL Server. Now, in terms of connecting to the SQL Azure, SQL Azure uses the TDS, the Tabular Data Stream Protocol. So if your previous versions of the .NET framework, you need to provide the complete path. So you say server.database.windows.net. Okay, like I showed you in the SQL Server Management Studio, give the full path to connect to the SQL Azure database. Now, if you have some legacy tools, so you may have to provide it in this manner. So you will have login at the rate of server name. Okay. Now, some of the things to take into account is that if you have long running transactions, they will be terminated after 24 hours, just to safeguard your database. If you have long running queries, you need to take care that they don't go over 24 hours. Idle connections will be terminated after 30 minutes. If a failover occurs, then connections are terminated, because we are creating a new instance of a database. So that connection is dropped and a new connection is created. So these are some of the things that you need to keep in mind when you're working with Azure. In terms of turnaround, like when you were working with SQL Server, the usual turnaround is what? 3 years? 4 years? With SQL Azure, it's 3 months. So the turnaround of technology is much faster. Every 3 months, either minor or major releases will be given to you in terms of either enhancing the technology or providing you new technology. Okay? Pardon me?
The previous slide.
Yes.
For the part that it says that it terminates the connection string whenever one of the instances late. So does this mean that I have to update the connection string within my application?
No. The connection fails. The connection string does not change.
Okay, so I will not change it.
No. The connection fails, but the connection string does not change. So you're connecting to a server, right? And you have 3 instances of the server. So it's a load balanced environment.
Yeah, that's what I know, but I got something different.
No. The connection fails, the connection doesn't change. Okay? We'll talk about these in the later session we have, so we'll skip these. Now in terms of reporting, how many of you have used reporting services, SQL Server reporting services? Now the same thing is available on Windows Azure. Okay, because SQL Server reporting services is a service by itself. So it's very easy to port that to SQL Azure. So the way you do that is you use the, what do you call, the report template from Visual Studio, and you deploy it with your Visual Studio application, right? So that runs on the SQL Azure reporting services. So you take your RDL template and you deploy it with your Visual Studio, and you connect it to your SQL Azure, and you can get real good reports from within. Now there are some limitations to this, like for example, Report Builder 3.0 is not supported on SQL Azure yet. Now in terms of SQL Azure, keep one thing in mind, that you do not have integrated security, okay? Because there is no concept of a domain. On Azure there is no concept of a domain. Your machines are not joined to a domain. So you have to rely on SQL Server authentication, right?
Or a standalone application.
Pardon me?
Or a standalone application.
For your standalone application, for reporting services, anything, even when you're connecting to SQL Server, it is done using the SQL accounts. There is no integrated security. So even from the SQL Server Management Studio, if you saw, I connected using a user ID password. There is no integrated security. Okay. So as I mentioned, some of the unsupported reporting features include report builders, subscriptions, scheduling. All these are currently not available. Custom extensions, report models, external images, these are not available, right? This is mainly due to the fact that we do not want to have any dependency on anything outside the database. Now let's talk about SQL Data Sync. Now SQL Data Sync or SQL Azure Data Sync gives you the capability of synchronizing data across on-premise database and cloud database, right? Now why is this important? You may have an application that is geo available, and you may have some data which is there on your on-premise database. Let's say you have a large organization which does point of sales across the world. Now your master data sits on on-premise database. So whenever that database is updated, you want to go and sync it to the hub. That is your cloud database. And then you want to populate the rest of the cloud databases which are there in the different data centers. So this technology basically allows you to do that. And let me show you. So if I come to Data Sync, I need to choose a region where I'm going to deploy my data sync. Okay, I create sync groups. So let me create a new sync group, give it a name. Then I give it a hub. This is a cloud database, right? So add a server and I add a database. User ID, password, click add. So this is not yet been deployed. I can add more databases either from the same data center or from different data centers. And then I can add on-premise databases. Okay? And then what this does is, since it's a hub and spoke technology, the hub is going to be populated first. and then the spokes are going to be populated. Now in here we have synchronization is either automatic or manual. So if I disable that, I can do a manual sync. Then you have to decide what kind of conflict resolution do you want to do. So does the hub win or do the clients win? So if, for example, if there is a conflict in data, which data prevails? Do you want the data that is on the hub to prevail or the one that is on the client to prevail? So you have to decide that. And then you decide on a data set. Right now I have no data in the database, but you decide on a database schema that you want to populate. So you can choose the tables, the columns that you want to synchronize. Right? You can even filter them. So you have row filtering also here. So you can only filter a particular subset of your data, a particular region, particular set of categories, whatever you like. And once that is done, then you deploy it and it becomes alive. So some of these things we have already covered. So this is provisioning the synchronization groups. We deploy the databases on the hub and the clients. We set up the synchronization schedule. We set up conflict resolution. We define the data set. You add the Azure clients. We install the SQL Server clients and deploy the topologies using the keys. So for example, if I have an on-premise database, I need to install certain agents because it's going to talk to the cloud database. We'll talk about that shortly. And then you deploy the database. You can manually synchronize that. Hub updates require one synchronization to distribute to all clients. As I told you, since it's a hub and spoke, all clients are going to update the hub first. Once the hub is updated, then the clients again will be. So you have two-way traffic going. Clear? Now, as I told you, if you want to have multi-tenant applications, SQL Azure is a very good candidate. So what you could do is you can have, for example, one tenant has two data. This particular tenant application has 1 GB database each, and you can charge them one model. Tenant 3 has a different set of databases. Let's say he wants 50 GB. Tenant 4 requires again probably 150 GB, and you can charge him differently. So this gives you an easy mechanism of creating multi-tenant applications depending upon the user's needs. Okay? So you can create multiple databases per tenant, or you can have one database per tenant. You decide in your application how it's going to be partitioned. Tenant is, like for example, you have an application which is payroll. Now that application, one business model is I come to your office and I install it on premise. So that's a one-on-one business model where each organization owns a copy of the application. The other model is one application serves multiple companies. So each company is called a tenant. So they share the application, they share the database, they share the resources, right? But they are internally split. The developer could do it one tenant, one database, or he could have one database and they are distributed by company ID, So it depends. But the whole idea is one application serving multiple companies. Like for example, Windows Azure storage. When you request a storage account,
Suppose I request something from Microsoft and let people use mine, you mean?
yes, that's where software as a service comes in. So you create your applications on this platform and you sell your service.
A good example about this is the authentication method for Windows Live. When I sign into other websites using my login on Windows Live, I use my ID and my password within.
I would not say that's a good example. A good example would be, for example, Windows Azure storage, right? It's a service that's running. But when you request for the storage account, you're giving your piece of that storage, right? You're given a part of that service. A new storage is not created for you, right? It's a huge data center which gigabits of data. You're just given a small chunk of it, right? So that's an analogy for multi-tenant applications, okay? Like for example, exchange, hosted exchange. When you go and say, I want to subscribe my company, they don't give you an exchange server by itself, right? They give you a part of that service. Your data is going to be sitting with other people's data, but you are going to be served as your own instance, right? So if you would like, we can take a short break. We still have time for prayer. So if you want, we can continue, and then in the middle we stop for prayer. What do you think?
Okay.
Or you want a break? 5 minutes? Continue?
How many times you gonna take?
How much time? Probably about an hour or so more. I would like to wrap up by 4.
Skill Azure is not possible without internet service.
No.
So why it is, previous situation was better, I think.
What do you mean?
Why we are depending on internet when we are going to create one standalone application.
But where's your application going to be hosted? Where's your application going to be hosted?
Like previously happened.
Pardon me?
Like previously happened. Previously there was no Skill Azure concept.
Yeah, but see, that's what I'm saying, is the world is moving to a connected scenario. People are depending more and more on connectivity and collaboration. So
At the same time we are bothering about the network traffic and all. Why this?
if you want to have a transaction on eBay, where do you go? Where does eBay store its data?
Correct. eBay or Amazon example is fine. But what about
Here we are talking about multi-tenant applications. There are so many companies as of today who are selling HR online, payroll online. You as an organization, clinics for that example in Saudi Arabia, many clinics, they don't want to have IT staff. It's a big headache for them. They can't maintain them, right? They can't maintain the services. They have to patch them. They have to make sure that there's no virus on them. There's no confidential data which is being taken away by somebody. It's a big headache. They're moving to an online option. Companies come in, give them access, set up the bandwidth, and they're ready to go. No downtime, no installation, nothing. You buy a subscription, second day you're ready to go.
Excuse me, a good example for the Azure is, for example, the cashier, for example, for a restaurant, for example, we sell a program for the selling.
Point of sales, yes.
Yeah, point
Yes.
of sales, and we distribute the data for each store.
You have many scenarios like this, and as you see, this trend is going to continue. It's going to go more and more into a connected.
Because it is a small databases and a normal data. It is not that much sensitive data.
Yes. So I'm not saying all the scenarios are going to move to, and said that in the morning also, that not all scenarios are applicable for the cloud, right?
This is what happened at the beginning of a new technology.
That's what I said. When we started with HTML and we talked about, let's say, 15 years ago, how many websites did you have? You had static websites. But then people started putting more and more. They started putting ASP.NET. Then you started getting e-commerce websites. People started putting their credit card information online. If you told somebody 15 years ago that I'm going to have a transaction on the net, how many people would have believed you? Not many. Right? So things will change with time. Technology is going to improve. Your connectivity is going to become better. Things are going to become much more streamlined. And you will see the gradual change from on-premise servers to cloud computing.
That's correct, but I'm just wondering about nowadays we are, if something is based on net, so
I know of companies, big companies, okay, not small companies, big companies who have their SAP systems hosted. Their whole HR is hosted. Their whole payroll system is hosted. They do not have any infrastructure at all. Zero infrastructure. Other than their desktops, they don't have anything. Their email is hosted. Their SharePoint is hosted. They don't want to have an IT staff.
and are you sure it cannot be hacked in future?
Hacking is no guarantee to anything.
So it's insecure.
No. Who can you guarantee that your on-premise server cannot be hacked? Can you guarantee that? Can you guarantee me that your on-premise server is not going to be hacked? There is no guarantee of anything. We say what is the possibility, and we take the utmost precautions to manage things. But we don't say anything is possible. See, if you look at the security that has been placed, the best of the security that is available has been put in place. You have physical security, you have logical security, you have firewalls, you have every kind of technology that you can find there to prevent things. But what will happen tomorrow, only time will say. You have seen companies like Sony, which were hacked. Did Sony not take the precaution to safeguard its servers? No, they did all the possibility, but then everybody is human. Okay?